Assalamualaikum warahmatullahi wabarakatuh to the fellow examiners. My name is Nurshahirah Izzati Binti Roslan, and today I will be presenting my thesis entitled Optimization of Environmental Conditions for Maximum Dye Decolorization of Crystal Violets by Nocardia asteroids. Dyes are extensively used in industries such as textiles, paper, leather, and pharmaceuticals. Due to their high stability and color intensity, synthetic dyes have largely replaced natural dyes in industrial applications. However, many synthetic dyes are toxic and resistant to degradation. When discharged into water bodies, they reduce light penetrations, inhibit photosynthesis, and pose risks to aquatic life and human health. In particular, triphenylmethane dyes such as crystal violets are of concern due to their complex aromatic structures, which make it highly stable and difficult to remove using conventional treatment methods. Conventional dye wastewater treatment methods, including physical absorptions and chemical oxidations, are effective but require high energy input, incur high operational costs, and generate secondary sludge. Moreover, these methods often fail to achieve complete dye removal. There is therefore an urgent need for cost-effective, sustainable, and environmentally friendly alternative. Although microbial treatment show promise, limited studies focus on optimizing conditions for dye decolorization using Nocardia asteroids. Biological treatments using microorganisms, especially actinomycin, has gained attention due to its sustainability. However, the decolorization efficiency is strongly influenced by environmental factors, and limited optimization studies focus on Nocardia asteroids, particularly for triphenylmethane dyes. The objective of this research is to optimize environmental conditions for maximum dye decolorization of crystal violet by Nocardia asteroids. The parameters, specifically biomass, dye concentration, agitation speed, and oxygen, then biodegradation analysis under combined optimal conditions conduct via Fourier transform infrared spectroscopy. Following the objective 1, Nocardia asteroids will be inoculated on ISP2 medium and incubated at 30 degrees Celsius for 7 to 14 days. In order to obtain live biomass, ISP2 broth will be used as a growth medium under similar incubation states. Then, the broth will be centrifuged and filtered for biomass of the species. Next, the dye stock solution will be prepared and diluted to working concentration of 100 mg per liter. The optimization studies will be conducted across biomass concentration from 0.25 to 1 gram, dye concentrations from 50 to 125 mg per liter, agitation speed from 50 to 150 rpm, oxygen availability, whether present or absent. Following the one factor at a time, each parameter will be tested individually while keeping the others at constant. Then, after the mixture incubated, the reading of absorbance will be analyzed to determine the changes in the concentration of dye over time. The second objective of this study is to determine the biodegradation of crystal violet under combined optimal conditions. After individually optimizing key parameters including biomass, dye concentration, agitation speed, and oxygen, this optimal level of these factors were combined to assess their synergistic effect on dye decolorization. Dye decolorization will be measured using UV-based spectrophotometer by monitoring absorbance reduction at 590 nanometer maximum wavelength. In addition, the FTIR analysis will be performed before and after dye treatment to identify functional group changes in order to confirm dye degradation has successfully occurred. To ensure the reliability and scientific validity of the experimental results, statistical analysis was performed using one-way analysis of variance ANOVA. ANOVA was applied to evaluate the significance of individual environmental parameters on dye decolorization efficiency by Nocardia asteroids. This study involved laboratory scale handling of synthetic dyes and live Nocardia species, which presents chemical, biological, and operational risks. Chemical risks include exposure to toxic dyes such as crystal violet, which may cause skin, eye, or respiratory irritation. Biological risks arise from handling live microbial cultures. All procedures were conducted following biosafety level 2 practices, including aseptic techniques, proper sterilization of media and equipment, and autoclaving of all biological waste before disposal. Operational risks such as spills, glassware breakage, and equipment-related hazards will be minimized through proper training, careful handling, and routine equipment inspection. This is the overview of methodology that will be conducted throughout the study. The research activities were systematically planned and monitored using a Gantt chart to ensure timely completion of the study. This study is supported by peer-reviewed literature from reputable journals and articles. The expected outcomes include identification of optimal environmental conditions for maximum dye decolorization and confirmation of dye degradation using FTIR analysis. This research contributes to environmental microbiology by expanding knowledge on the dye-degrading potential of nocardia asteroids. In conclusion, this study demonstrates that nocardia asteroid has strong potential for dye decolorization, and optimization of environmental conditions significantly enhance its performance. Thank you.